In part two of the videos regarding section 4.4, let's break down a little more detail and look at the construction and how the voltage is generated now with multiple coils. When we look at figure 4.7, we this is a schematic representation of a DC generator having 4 coils and 4 commutator bars. This is what our output voltage looks like from there. And we'll also contrast the schematic diagram to an actual physical construction of the generator. All right, so let's get back to 4.7, and I'll point out a few things here. And when I feel like your eyes are glassing over, we'll stop this video and start another one. But we're going to call this coil A, and this is coil C. Now, it's important to see that both of these coils are not under a magnetic pole. So the voltage developed on coil A or coil C is what we're going to say 0. So we're saying those would be 0. And we've also got coils B and coils D, and those are actually cutting. As you know, you think about this thing rotating. Again, this one's rotating in this direction according to our figure here. And these 2 coils at the particular point that we're looking at are cutting the maximum flux at that time. So they would be producing the maximum voltage. So A and C, 0, B and D, we don't know what the value is, but it would be maximum voltage. And that voltage is, described, or, it's proportional to the, again, the flux density, the length of the coil, the actual physical length, and how fast it's turning across there. So the schematic diagram in figure 4.7 tells us where the coil sides of the individual coils are located, between the poles, under the poles, near the pole tip, so forth and so on. But we also need to remember that each coil side, and here's one side of the coil, and here's the other side of coil A. All right, and what it's supposed to represent is that coil is laid into a slot. One side is laid into a slot. It runs the length of the armature, goes down, terminates out the other side. So these 2 sides are actually 180 degrees apart from each other. So this would be one side of coil A, and this would be the other side of coil A. And here's, the same thing for coil B. Here's one side of it, and here's another side of it. And here's D, and here's C and C. So that represents the 2 sides of the coil. Now, again, I want you to think of that armature, and these coils run the length of it, and they're laid out, and they lay one side down, they go down, and they terminate out the other side. And so they run the length of it. Now, it's a little hard to see that, in this schematic diagram. And that's why we're going to contrast that to a physical diagram. So let's do that kind of while we got this in our brain. And I'll point out a couple of other things before we do that, before we actually get there. So we're looking at all parts of this. But here's the brushes that we talked about. Here's brush X, and here's brush Y. And we could see that, something, I'll go ahead and point this out. At this particular point, the brushes are connecting the 2 sides of coil A at a point to where no voltage is generated. How do we know that? Because that commutator segment that is non-conducting is sitting right there on the brush for this guy. Okay, so anyway, I just just wanted to point that out. We'll go into more detail about that in just a second. Now let's go fast forward here to the actual physical construction of this same generator, and I think this brings out some things clearer to us in the actual construction. Okay, so here again is coil A, and it is laid into the slot. It would run the length of that armature, terminate on the back side, and look, it comes out here, and it's 180 degrees opposed from one side to the other side. And these are slots that are cut in the metal, and these coils are laid in the slots. Here's another one. Here's coil B, and here's one side of it, and over here is the other side. Now, something that we call a lap winding it simply means that one side of the coil is on top and the other side is on the bottom, and it's lap wound, and that's why they call it that. It also shows us on here that this side of the coil A is connected to a commutator segment that we're calling A, and this side of coil A here is connected to a commutator segment that we call B. Okay, and so we're looking at this in terms of an electrical schematic, but we're also thinking of it now in terms of the actual physical construction of this thing. And again, here are our brushes X and Y, and from those brushes, that's where we pull the voltage that's generated. All right, let's stop this video, and we'll give you a break on that and get ready to look at something else here.